Okay, so this is going to be how to get a basic water boat wake effect for a boat, obviously, but it can apply to whatever it is you're doing. Um, this is just a basic one. So to do that, we're gonna bring in, say, basic object. In this case, we can go in here, and to do it, we're just gonna use one of the test geometries. Uh, Cute little rubber toy. We're just gonna use him to do it. Now, he's gonna need some animation because, of course, the boat wig happens when it's moving. So, um, I learned it's really useful to apply your animations to a null object in this case, and we'll just connect the input of the geo, which will name it'll be tub. Just name him Rubby, so you don't get confused. We'll apply all the animations to the null because then if, for example, we wanted him to move side to side or have his own special animations, it would not affect the nulls. The null is, for this case, is just going to be so he can move. And in this case, we're just going to have him move at $FF, capital FF, divided by, we'll give it a decent 10. Really doesn't matter, but actually, we'll change it to 3. We'll give it a low number. And this is just going to first move him in the z-axis. Don't really need to see the null. Now, we'll of course start zipping around, but fact will also decrease the frame rate. We don't need it. Now, to get the water-like effect for or the wake effect, I'm going to use something called a flat tank. Now the reason why I'm using this is it's really good at tracking moving object. So like how we have our Rubby here moving, and if we would have an animation for a boat, like a jet ski or something, moving, this would be able to track without us having to like use any of the other fluid containers or other ocean containers or water containers and making it really big for our animation. Um, that's like my computer is good, but it's not that good. So it's much more efficient to use a flat tank. So to do so, just going to get it to work, you just have to click on it, and down here it says select objects, select, enter, and now it has to calculate to create the flip tank, to create everything, and to get it ready. And now we're in the clear. It immediately brings you to um, into the flip tank initial. Now that's I'll tell you in a second what that is, so you're immediately confused. Now it makes all this all this confusing fun stuff when you first ever use it. But as I've learned from this, it is not actually hard to figure out. This is all the stuff to make the white water. So all the white water that comes from the boat moving from Flippy here moving through the water. That's all that does. So the simulation, the source, the input into the solver. And this is all that's created from the flat tank. And our Nolan, RBR over here still. That tank, this was what it brought us into. This is where it merges the object in, merges the collision. This deals with all the collisions. This is the powerhouse between the particle separation, like in the um any other water sim. So it's if we want it a little bit prettier, we would of course bring it closer in. This as you see, turning down the particle separation makes it pretty in the end. It's pretty intensive. So we're just gonna leave it back at its 15. Now that's just what that will do. This is the render, so already ready to go render. You could go right now, light it, capture it, be good to go. But then you wouldn't know what you're doing. You just know how to get it going. But how to use it, this is another bring it in. Um, Most of your work will be done in here because this is where you play with the resolution, which is the particle separation. This is also where you will deal with the boundary layer, which like how I said earlier, the flat tank tracks with the object. What it does is you can see with these visualization, you can check it out. This green box here, particles. It's like a flat tank's or any other tank's wall. When particles hit, it deletes them. What this does is it fills it in. So as it's moving forward, it's deleting the particles behind, like here, and refilling particles in here. So it's constantly having the same water level. Um, you want to have a decent size padding. Like you can have it whichever size you want it. If you want it a nice good box like how we have here, you can do it. You can also change the color size, but not 100% necessary. Um, Also, you get in here is a sometimes CD can be a little bit of a pain, as we all know. You get a handle when you're on this, and all this does is moves around, sizes the box itself. It doesn't size the boundary layers. What it's doing is sizing the box. This is where you deal with the padding itself. Um, Now, of course, that's not. This just makes it shallower, whichever size you want it. If you want water level specifically, it's in the particles node over here. That's where you adjust this, but you don't 100% need to. It's fine how it is. Um, Now, the biggest concern when using this is to see it, we have to go back to our null. So let's say our translation is too fast. So we just had the FF. What happened is, if we had just FF, you would see the particle thing try to keep up, but it couldn't. As in, you can just try and show. As soon as it renders, what will happen is it can't fill the padding layer, or the boundary layer, I'm sorry, does not have, cannot fill the loss of particles fast for the particle moving. You can slightly see a little bit of layer, but we it so happens that um, I had adjusted the boundary box well enough to not, uh, but you would see like, yeah, if it was happening, if your thing was moving too fast, like let's it was we need to increase floppies or rubby, my bad, speed a little bit faster to see this effect, because this is the main problem. So to know this before you render is anything you want to worry for. So let's say $sign FF times 5. So 5 is going to move really fast. So once we let it cook, it's going to move. And see, as you can see right there, that is what happens when uh, the speed is a little too quick for the boundary box. Now you can adjust this by either decreasing the speed to match, or you can better increase the boundary box to give it time to um, get rid of the particles and add in the particles so it matches the speed you're testing. Like if you want it to move this fast, don't change the speed, change the particles so it can fill in. And so we're just gonna go back to our nice little slow speed, and you can zoom in, and like as from the start, you can see once it cooks, it's creating the white water, it's creating the little lake behind it, and it's all ready to go. You could slap in a light, slap in a camera, adjust a little stuff, add you want. And one final note: to get tracking to really look good instead of just the boat and the water just leaving you, you want to do the same effect you did with having Rubby here follow the null's influence by tying your camera and your light. You just add up here. We're gonna delete that node. We're just gonna control click, and we're gonna add an environment light. It's just gonna sit there. Now we're gonna bring these two nodes over, and we're gonna do the same with how we did Ruby by connecting their inputs to the null. As we go into say in our camera view, we should, with the play, keep up with Ruby here. And this is where we can actually see the uh, water being created by the white water, and would be the boat wake if we had the. You could really see close if you had the camera zoomed in. But that is all you need to do to get a roughly basic boat wake, and you can go in, change the little things around, and make it look pretty. Well, thanks for watching. It was helpful.